Means between A and B, the variation of bending moment having a nature of inclined straight line. Now put x is equal to 0, bending moment at A is equal to 0. Now when x is equal to 1, 7 into 1, 7 plus sign bending moment at B. So this is of magnitude of 7 inclined straight line, 7 value plus sign. So now understood how we achieve this one. Next, taking a section between B and C, which is shown over here right now. X is the distance over here. This is of 1 meter. What is bending moment at XX? Is equal to 7 into 1 plus x, section left clockwise, minus 12x, section left anti-clockwise, creates the hogging nature, minus 12x. Now, when x is equal to 0, my bending moment at B is equal to x is equal to 0. So this term is nullified. X is equal to 0, only 1 is there, 7 into 1 is 7, that we have achieved over here. Next, x is equal to 3 meter. So we can achieve the bending moment at C. So when we go for x is equal to 3, then 3 plus 1, 4, 7 into 4, 28, minus 12 into 3. So we got bending moment at C is equal to 28 minus 36 is equal to minus 8. So we got over here the ordinate is of 8. Minus means below the baseline. Minus means below the baseline. And joining this point and this point by inclined straight line. Because there is no load, variation is given by inclined straight line, and this equation suggests also inclined straight line. Next, take a third section between C and D. We are taking a section over here at distance x from C. My bending moment at xx is equal to 7 into 1 plus 3, 4 plus x, minus 12 into 3 plus x, reaction RC, plus 13 into x. 3 components has been taken care over here. The first 7, distance is this one, 1 plus 3, 4, 4 plus x. Next 12, 3 plus x, 12 into 3 plus x. Next 13, that is nothing but my reaction, 13 into x. 3 different forces are there over here right now, with their sign conventions that has been adopted right now. Now, when x is equal to 0, my bending moment is at C, because my x is from C. X is equal to 0, BM at C. This component is nullified. This is 0, so 7 into 4, 28, minus 36, it is minus 8, that we have already been achieved. Next, take x is equal to 1 meter. What happens? 7, 4 plus 1, 5, 7 into 5, 35, minus 12 into 3 plus 1, 4, 12 into 4, 48. So 35 minus 48 plus 13 into 1, that is plus 13. So I will repeat the word once again. Bending moment at D is equal to y at D, because when x is equal to 1, bending moment is at D, is equal to 7 into 5 minus 12 into 4 plus 13 into 1. 35 minus 48 plus 13, which comes to be straightforward 0. Joining these 2 points by inclined straight line. So we achieve plus sign, this 2 as minus sign. So now this bending moment diagram we have achieved. There will be a certain important point that we have to notice down over here. First, between 2 point load, if there is no load, the variation of bending moment is given by inclined straight line that we can visualize. So we can see my bending moment diagram is made up of 3 different inclined straight line because 1, 2, 3 and 4 forces are there and no load is acting between those 4 loads. Second issue, there is a certain point where bending moment is 0. This is a new concept, this is a new point. Up till now we have discussed in various lectures, this point is never arised. The point where bending moment is 0 is known as point of Contra flexure. It is very much interested and important point to note down. This point is known as point of Contra flexure. Some people use the word point of inflation. Either point of inflation or point of contraflexion, and it is our utmost important to find out the distance where this point of contraflexure is acting. So our intention is right now to find out this point, the distance from A, the point at which the bending moment is 0. Let us be found out. Now to find out that particular point, we have to make certain important notice over here. The first important notice, that my contraflexure, point of contraflexure is between B and C. This is my first observation, that the point of contraflexure is between B and C at anywhere. So I have to take a section between B and C, and that is the figure for over here. Between B and C, this is the figure. Let us take and draw over here. Please carefully visualize over here. This is my section 12 kN, 7 kN. This is section XX, distance X from B. This is A, section XX. So what is my bending moment equation? We have achieved it as 7 bracket 1 plus x minus 12x. This is the basic equation. Now this bending moment is equal to 0 because it is 0 over here. This is equated with 0. So if we simplify, 7 plus 7x minus 12x is equal to 0, and we get 7 is equal to 5x, and we got it, x is equal to 7 by 5. What is 7 by 5? 1.4 meter. 1.4 from B. So this is 1.4. So from this it is of 1 plus 1.4, that is of 2.4 meter. So I achieve x is equal to 2.4 meter. Point of contraflexure, the point at which the bending moment is 0. I wish now it is clear to you how to plot the bending moment diagram. You can also find out this point of contraflexure by taking two different triangles using the mathematics. How? Let us see over here right now. This is the figure is with us. So I will plot the diagram like this. Intermediate portion, I am going to take this portion. I am plotting this portion as an individual over here. 7, 8, and let us, this distance is x. So what is this distance? Yes, it is 3 minus x. Now using the application of mathematics, this angle and this angle are same. This angle is theta, this angle is also theta. As per that rule, I will use tan theta. What is the tan theta? Yes, opposite side by nearest side. 7 by x is equal to, once again tan theta, opposite side by nearest side. So we achieve, simplifying this now, there is no need for me this tan theta, forget this tan theta, only use this and simplify. 3 minus x by x is equal to 8 by 7. Simplified it over here. 3 by x minus 1 is equal to 8 by 7. Therefore 3 by x is equal to 1 plus 8 by 7 is equal to 7 plus 8, 15 by 7. Therefore x by 3 is equal to 7 by 15. Therefore x is equal to 7 into 3 by 15. 7 by 5, we achieve 1.4. The same answer, the answer we can got from an equation over here right now. The same answer we got, that is of 1.4, and same answer over here. Now, but this method is applicable only the case where the relationship is of inclined straight line. Then and then you can use the application of mathematics, that is this angle is theta and this angle is theta. Otherwise you cannot use this concept. You have to use the concept of equation at section x-axis. You have to use this concept only if there will be some relationship of curvilinear nature. So now let us visualize the same diagrams over here on this PPT. This is my shear force diagram. Please on the PPT. Yes, this is my shear force diagram where three different rectangular blocks will be there. As why this? Because there is no load between these 2 point loads are there, and we have understood over here in the tabletop also. Next, this is my bending moment diagram. The point at which this bending moment is 0 is known as point of inflation or point of contraflexure. Fine. I wish you have understood these two things very clearly, and let us proceed further with the next particular problem. Number 3. Problem number 3, which is consisting of a beam with UDL. Before we proceed further, you have to do this problem at your room, at your home, at your college. Try to understood very carefully. See the problem over here. The overhanging beam is there, length of 4 meter and 2 meter, that is the overhanging projection is of 2 meter, subjected to the UDL throughout. So step number 1 for us, determination of reaction, and we have already take a various series of lectures for the determination of reactions, so you can easily find out the reactions. After finding out the reaction, draw the shear force diagram and bending moment diagram by taking a section, as well as check the fundamentals that if there is a UDL, the variation of shear force which is given by inclined straight line, and the variation of bending moment diagram which is given by a parabolic nature. I will take this problem once again in the next lecture, but let us give you the brief hint that the reactions are of the reaction that we achieve over here, that is 45 kilonewton, that is RB, and 15, that is of RA. And this is the shear force diagram, this is the bending moment diagram, and this is the point of contra flexure that you have to find out, that you have to solve at your room. Fine. So now today we have solved certain numericals based on the concept of equilibrium, and we have plotted the SF and BM diagram for overhanging beam. I wish you have understood very carefully and try to solve or make or solve so many numericals at your room. And in the next series or in the next lecture, we will solve, or we can solve the more numbers of problems. Thank you.